For our scenario, here's the scoop. We have some VMs, VM TC01 through 08. If they are booted in order, not all of the VMs will boot up. So as we confirm the symptoms, we'd want to boot all those VMs and take a look, including any alerts or messages that are given to us during the boot process or attempted boot process. And one other scenario that's having a problem is a VApp. There's a VApp inside the vSphere infrastructure that has 3 VMs as part of it, and the VApp won't start. So we've been called in to verify what's happening and then to resolve the problem. And I'd like to pause right here for just a moment and give you the opportunity, if you'd like it, to go ahead and do this troubleshooting before you go through the walkthrough we're about to do together. And regarding the current problems that are embedded in this lab, the technologies and the reasons and the solutions regarding those VMs not booting, we have covered those technologies previously in this course. So I'm going to put some music on for a few seconds to give you a chance to pause this video, and that way you can go ahead and do the lab first. And then if you get stuck, or if you just want to compare notes, go ahead and continue the video, and we'll walk through the confirmation of the problem and the resolutions together. We are logged on to the vSphere web client. We're currently logged on as administrator at vSphere.local. And we're currently in the navigator under host and clusters with cluster 1 selected, and on the summary tab for cluster 1. So let's verify the results. Now there's lots of different ways of launching VMs in the interface. And because currently we're at the cluster, let's go ahead with the cluster selected. We'll click on the VMs tab right here. And we'll go ahead and make sure we're sorting by name here. So if we click the column header, it can click ascending. You click again, it'll go descending. We're currently sorting based on the VM name column. So these are the VMs that we're interested for starting off right here. So let's go ahead and launch them. And if they said they were having problems coming up in order, that's how we would want to test them as well. So we could highlight VM TC-01 and click on Start, and then just repeat that process for 2, clicking on it, clicking on Start. Now, if we do get bored with starting them individually, we can certainly highlight one like TC03, and then hold down the Control key, and then click on the row for 4. With them both highlighted, both selected, we can go ahead and click on Start here. That would power on both of them. But one risk that we do run is that if the customer said, if we start these in this order, we have this problem, and by starting 2 or more at the same time, it's possible that because we're not following the exact same process that they're describing the problem with, that we might not have the same errors. Now, so far, these 4 virtual machines appear to be running, and if we just wanted to test one of those, if we highlight the row for TC-02, that VM, and open up a console to it, we can do that with this icon right here. Now, before we start working with this virtual machine, we'd want to take our mouse and click somewhere in this space here to give the focus to this virtual machine, and then we can start typing. So as an example, if we want to do commands like ifconfig to look at the interfaces, Ethernet 0 has an IP address of 10.33.104. And we can verify connectivity by doing a ping to an internet resource, which is a Google DNS server. And that looks great. We'll do Control-C to stop that ping. And we can do tools like NSLookup and look for www.google.com. So here's the name server that we use for the resolution. And then it returned an IPv4 address and also an IPv6 address regarding google.com. So it appears this VM is functional. So I'm going to click on the lab window and press F11. To take my browser out of full screen so I can go back to the vSphere Web Client tab right here. So let's start up the other VMs. Looks like VMs 1 through 4 are fine. So we'll click on the row for VM TC05. Go ahead and click on the Start button to start that one. And if we go to Recent Tasks, that seems to be starting as well. Okay. Then we'll go to VM6, selecting that row, clicking on Start, and we have a failure. And the message says, vCenter server was unable to find a suitable host to power on the following virtual machine, right there, for the reason listed below. Well, this is going to be good. Great. So the available memory resources in the parent resource pool are insufficient for the operation. And that's the same error that we're seeing right here as well. So if we click on OK to that, and let's take a close look at the configuration for VMTC06. Now we can do that by clicking on it right here, the hyperlink that'll take us specifically to the details for that virtual machine. So with it selected over here on the left in the navigator panel, we have the summary tab, and on the summary tab it's showing us that it's in a resource pool called RP-HR. We can also visually see that here. So we have a resource pool called top, and within that resource pool there's a resource pool called engineering and another one called HR. and TC06 is in the HR resource pool. So the message we got was indicating that there wasn't enough resources in the parent pool. So the parent pool is the HR pool that this virtual machine 06 is in. And from a parent-child relationship, the HR resource pool is a child to the parent top resource pool based on this visual layout right here. Now, the reason it would complain about the resources not being available like it did was because we have a reservation right here on this virtual machine, and this resource pool that it's in can't meet the reservation. If VM6 didn't have a reservation, we wouldn't be getting the message that the parent resource pool can't meet that reservation. Now, there's several ways of viewing the information regarding reservations. We could right-click on VM06, and from the menu, we could go ahead and select Edit Resource Settings. It would show us there. So by clicking on Edit Resource Settings for VMTC06, it's showing us that we have a CPU reservation of 1 gigahertz or 1000 megahertz, and a memory reservation of 1024 megabytes or 1 gigabyte. Another way of seeing that information would be to go to the resource pool itself. So if we click on RP-HR, the Human Resources Resource Pool, and then we click on the Monitor tab regarding that resource pool, and then from below that we click on Resource Reservation. This is a great way where we can actually see the reservations associated with this pool and the items in this pool. So with the resource reservation here selected and then clicking on CPU, this is going to show us the reservations as they relate to CPU. So this Human Resources Resource Pool right here has a configured reservation of 2.5 gigahertz that can be used to support objects in that resource pool that have reservations. And currently we have 2 VMs that are running, and they are both reserving 1 gigahertz each, 1000 megahertz. And that's being reflected here. And because the entire pool only has 2.5 altogether, it only has 500 megahertz, half a gig, of CPU left, which doesn't meet the reservation requirements of VM06, which is why this machine cannot power on. Now, this is for CPU reservations, and that wasn't actually the message that came up. It was referring to memory. So if we want to look at the memory reservations for this resource pool, we can go ahead and click on memory right here in this middle column. And what this is showing us regarding the pool, regarding memory, it's got 2.35 gigabytes of memory as far as a reservation for the pool, which means it can support up to that much for reservations regarding memory for objects in that pool. And currently, these 2 VMs, VM4 and 5, are currently running. They both have reservations in place and they're running, and that's why the used reservation is showing up here as a little over 2 gigabytes of RAM. And there's only 244 megabytes left, which again is not enough to support VM6, which has a 1 gigabyte reservation. So as we look at the possible technical solutions, we have several. And the reason I've put the technical in air quotes is because we may have some restrictions that we still need to follow based on the design of the vSphere environment. But technically, there are several ways that we could solve it. Number one, we could take this virtual machine here and we could reduce or remove the reservations. So if there's no reservation for this virtual machine, it won't be prevented from booting in this pool because it's not requiring a certain amount of CPU or memory that from a reservation perspective, the pool can't deliver. So we could modify the reservation at the VM level. That's one option. Number two, we could go ahead and we could change the reservation type from fixed to expandable. If we set it to expandable, this resource pool will go to its parent. In this example, it's the top resource pool. And if the top resource pool has the either gigabytes or gigahertz regarding RAM or CPU available from a reservation perspective, who can then allocate that to the virtual machine that has the associated reservation. So that's our second option. And the third option would be to move this VM. If we move this VM out of this resource pool and we move him to another resource pool like the top one, or we put him directly in the cluster, then that VM for its reservation could pull from the top pool if that's where we put it, or if we put the VM in the cluster, it could get its reservation from the resources in the cluster. And one question that may come up is, well, what if we put this VM directly in the cluster, for example, not inside of a subsequent resource pool, but in the cluster itself directly, and it still can't boot up because its reservation can't be met? Well, at that point, we would reduce or remove the reservation on the VM, and that would allow it to come up. Or we could add additional resources to the cluster by adding another ESXi host with additional CPU and memory, which hopefully would be enough to satisfy the reservation for a VM and allow it to boot. So for this solution, let's go ahead and modify the properties of VMTC06 and either reduce or remove the reservation. So what we can do is simply right-click here on VMTC06, and from the menu we can go directly to Edit Resource Settings. That's the quickest way to get there. And then simply change the reservation. So I'm going to set the reservation for memory to 0, because that's the reservation it was complaining about, not allowing it to boot. However, if we clicked OK here and give it a moment to refresh, so now looking at this pool with the monitor tab selected, looking at resource reservation with memory selected, it's now showing that VMTC06 does not have a reservation, and as a result, the parent, in this case the HR resource pool, doesn't need to have a reservation for that virtual machine because the virtual machine is not asking for one. So we've solved the memory issue, but if we click on the CPU option regarding reservations, I see here that VMTC06 has a 1 gigahertz CPU reservation, and the pool only has 500 megahertz to give, half a gig. So if we try to boot this virtual machine, we can do it right here just by right-clicking on the virtual machine, and then hovering over power and clicking power on, or we could just highlight it here and use the shortcut for power on right above it. And sure enough, now the message is coming up, the CPU resources aren't available. Alright, so we'll click on OK. We'll right-click on the VM, Edit Resource Settings, and regarding the CPU reservation, we'll use the drop-down, select 0, click OK. And now, regarding VMTC06, with that row highlighted, we'll use this icon here to power on the virtual machine. So now it's in the process of booting up. We can click on that row, click on the icon to open a console, and there's TC06, up and running. And a quick ping to google.com, and then a Control-C to stop that, verifies it's up and running and has access to the internet. So if we go back to the vSphere web client, we still have a few VMs left to go ahead and boot up. So if we go back to the cluster level on the left, so we'll select cluster-1 on the left, we'll select the VMs tab, and then with the subsection of virtual machines selected, let's go ahead and scroll down in this list, and let's power on VM7 and VM8 as well. So we'll simply click on that row for VM7 and click on the icon to boot that virtual machine. Give it a moment, verify that it powers up, and it does. That's great. And then VM8. So maybe we're done. So we'll go ahead and click on the row for VMTC-08, click on the icon to boot that virtual machine, and we have a power on failure message, which indicates the amount of CPU resources available in the parent resource pool is insufficient for the operation. So we'll click on OK, and we'll go ahead and click on VM-TC08 to go ahead and bring it to focus here in the navigator pane. And this indicates visually here that it's actually in the top resource pool here. It also is indicating that over here under the related object section. So the resource pool it's in is RP-top. And so that parent resource pool is causing grief for that VM starting. So if we click on RP-top to select that resource pool, and then we go to Monitor, and then click on Resource Reservation, we have the options once again for CPU and memory. If we click on CPU here it's showing us that VMTC-08 has a reservation for 1 gigahertz, and currently we only have 500 megahertz, half that amount, available for reservations inside of this pool. And if we want to take a look at memory, we could click on memory, which is also going to be a problem because this guy has a 1 gigabyte memory reservation, and the pool doesn't have the gigabyte of memory as a reservation to allocate for that VM to come up. So to solve this, instead of changing the reservation on VMTC-08 for CPU or memory, let's instead modify the reservation type for the top resource pool and tell it that it's expandable. If we say it's expandable and it needs additional reservations for its objects inside that pool, it can go ahead and go to its parent, which is the cluster, and if those resources are available as reservations, it can go ahead and get those real time as those VMs come up. So to make that change, we'll right click on RP-top, that reservation pool, and from the drop down, we'll click on Edit Resource Settings. So regarding reservations, regarding this resource pool named RP-top, let's go ahead and make them expandable for both the CPU reservations and also for memory reservations. So with both reservation types now set to expandable, if we click on OK, let's go ahead and once again attempt to launch VMTC-08. Now because we're right here on this resource pool, RP-top, we can go ahead and simply click on the VMs tab regarding that resource pool, and it'll list all the virtual machines that are contained either within that resource pool or a subsequent resource pool below it. So we'll go ahead and highlight the row for VMTC-08, click on the icon to boot that virtual machine, and this time it comes up. And that's because the reservation type at that pool level was expandable. So if we go back to the Monitor tab for this resource pool and click on Resource Reservation and then click on Memory, so now it's showing us that even though it only has an 8 GB reservation configured at itself, because it's expandable and because the parent has more resources still available, we can still handle object, either VMs and or other resource pools with reservations. Because the resource pool is expandable, it could go and get those additional reservations if they're available from the parent. In this case, the parent is cluster 1. Great, so we've solved the problems of VMs 1 through 8 not all booting. The other challenge that was mentioned is that the VApp would not boot. So if we click on VApps right here, it's currently not showing us any VApps because there are no VApps inside of this RP-top resource pool. So if we go up to the cluster and we look at the same view, let's do that. So we'll click on the cluster, cluster-1 on the left-hand side. And with that selected, if we click on the VMs tab, and then below that, if we click on VApps right here, it'll show us any VApps in the cluster. There we go. So there's VApp-1. If we click on that over on the left-hand side, it'll show us exactly where it is in the hierarchy. So here's VApp1, and if we expand that, it's going to show us the individual VMs that are part of that VApp. So let's power this on and verify whether or not it boots. So with VApp-1 selected, we'll go ahead and use the icon for powering on this VApp, which will in turn, or should in turn, power up each of the VMs inside of that VApp. And here's a message right here. The amount of CPU resource available in the parent resource pool is insufficient for this operation. Now at first blush we might think, well, VApp-1 is inside directly, it's inside cluster 1. So does that mean cluster 1 doesn't have enough resources reservation-wise to boot the VApp? So let's take a look at the parent. If we go to cluster 1 by clicking on it here on the left, and then we click on the Monitor tab for cluster 1, and then below that, if we click on Resource Reservation regarding the cluster, so here regarding Resource Reservation focusing on CPU, it shows us that the capacity for reservations is 23.35. It's currently used 16.2 of that, and it still has over 7 gigs to offer. And if we look at the VApp, here's VApp1 itself, it's only asking for 2 gigahertz. That looks like enough. And if we take a look at the memory regarding reservations for the cluster, it's got a reservation capacity of over 23 gigs. It's got 16 in use. And available reservations for memory is over 7 gigs. And here's VApp1, which is only asking for 2 gigs. So to solve this, let's take a closer look at VApp1. So let's click on VApp1 on the left-hand side in the Navigator panel. And with VApp1 selected, let's go ahead and click on Monitor, the Monitor tab, and then we'll click on Resource Reservation regarding that VApp. And herein lies the problem. The problem is that these VMs have individual reservations, and the VApp itself does not have enough reservation to meet the needs of the VMs inside of that VApp. So it would need 3 gigahertz as far as a reservation for CPU to bring up all of the VMs inside of that VApp. And if we click on memory, it's also going to be a problem here because each of these wants a gig of RAM and it only has 2 gig overall. And so it's like the 3 Musketeers, all for one and one for all. If we can't come up as a VApp, we're not going to do it. So to fix this, we could modify the reservations on the individual VMs that are in the VApp to make them less, to make them fit inside the reservation that the VApp has for both CPU and memory, or we could increase the reservations for the VApp. And another option is we could make the reservations on the VApp expandable. Very similar to what we did on our top resource pool. So let's modify the reservation for memory and CPU on the VApp itself. So we'll right click on VApp-1. We don't have a shortcut here on the list to modify the resource settings, so we're going to have to do it the long way. So we'll click on Edit Settings, and from Edit Settings we're going to expand CPU resources, and we're going to expand memory resources. Here it shows us those respective reservations, and if we want to make them expandable, we just put a check in the checkbox for each of those reservations to change the reservation type, and click on OK. So to launch this, we'll go ahead and make sure that VApp-1 on the left is selected, and then we can go ahead and use this shortcut here to power on that VApp. So we'll click on Power on VApp, and now because the reservations can be met for each of the VMs in the VApp, it'll go ahead and boot those VMs. So I have them on a short delay, so VMA will boot up, and then after a short delay, VMB will boot up, and then eventually VMC, and we can monitor that progress here in the recent tasks as well. So here in recent tasks, it's indicating that VMC is just finishing powering up. Fantastic. And now that that's done, we'll go ahead and minimize recent tasks. And if we want to go take a look at one of those VMs, we can simply select one of the VMs, by highlighting that row and then clicking on the shortcut to open a virtual machine console over to that VM. So we'll do that for VM-C, and there is VM-C booting up. So here is our VM-C as part of our vApp, and if we go back to our web client, we could go ahead and select vApp1 and go ahead and use the icon to shut down the vApp. And because the VMware tools is installed on each of the VMs as part of that vApp, it can be a graceful shutdown of each of the VMs. So we'll go ahead and shut them down. We'll click yes to confirm. And then regarding all the other tiny core VMs, if we want to power them off together, we can click on cluster 1 on the left. And with cluster 1 selected, if we click on the VMs tab right here, and then we click on the virtual machines option, it'll show us all the virtual machines inside the cluster. So it looks like VMA and VMB are still in the process of powering down, which is fine. So if we wanted to power down all of the TC VMs, we could go ahead and click on the row for the first one, VMTC-01. So with that first one selected, if we hold down the Shift key and then click on the row for VMTC-08, that's going to highlight all 8 VMs for us. And if we wanted to, we could go ahead and click on the shutdown icon right here to power them off. Another cool thing we could look at before we power them off is we could go ahead and click on the Summary tab for the cluster and take a look here at the vSphere DRS at how well it's doing balancing. And if we clicked on the Monitor tab for cluster 1 and then selected vSphere DRS right here and then clicked on the History option, it can show us the history of what vSphere DRS has been doing for us. So in this nugget, we've had the opportunity to do hands-on practice to identify the reasons for and resolve virtual machines not booting in a vSphere environment. So I hope you enjoyed this nugget, and I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.